All right, I think we can get started. I have to say, I was waiting for that guitar riff at the start.
Yeah, me too. Guess we'll have to create our own.
It is what it is. Hello. Thank you very much for joining this session on reaching operational excellence using OpenTelemetry. Who has heard of operational excellence before? A couple of people? Okay, good. So I hope we'll teach you something today. Who has heard of OpenTelemetry before here? A little bit more people. Okay, that does make sense. I am Alexander Chatzizacharias and Riccardo Lippolis, right?
You say so smoothly.
Yeah. It's a little bit of tricky last name because I'm half Greek and half Dutch. And you are?
Half Italian, half Dutch.
Yeah. So there is definitely a little bit of a rivalry going on between us. I was wondering, who here has been to Greece by any chance? Who here has been to Italy?
Yes.
Okay, I should probably not ask the following question.
No, go ahead, ask it.
Who here prefers Italy over Greece by any chance? Who here prefers Greece over Italy? Oh man. I lost another one.
Yeah.
Huh? But the food is just so much better.
Sure.
So I come from a .NET background. And like 3 to 4 years ago, I switched to the JVM. And I've been doing Kotlin exclusively since. And I have to say, I don't know who here was at the opening keynote, but hearing, join the Kotlin Army song, that touched me really straight in my heart, I'll be honest.
You're part of the Kotlin Army now, eh?
I'm part of the Kotlin Army now. And you?
Definitely. Yeah, I started out with a Java background, but ultimately also made the switch to Kotlin and don't want to go back.
Never look back. And we both work at a company in the Netherlands called JNation. It's a very small consultancy, or very small. We're like 30, 35 people or something, okay. All GVM crazy, so to say.
Yeah.
And we are here today to talk about operational excellence using OpenTelemetry. So roughly 3 years ago, I joined a project. It was my first project doing a lot of microservices and stuff like that. I was working a lot with simulations before. And then you were on the project and you started saying this term operational excellence to me.
Yeah.
And to me that meant nothing, absolutely nothing. So I am a little bit of I think the correct term in Portuguese is gaucho. There's like a cowboy style person, right? So I really like to, push the production as soon as possible, fail fast, fail often.
That is mostly failing.
Mostly failing, yeah. I don't. Anybody else who likes that, way of living?
Cowboy attitude.
A couple of people, okay. Nice. But then you start talking about operational excellence and caring about your production environment and what it means to have a healthy production environment. And then we're talking about what it means, what operational excellence is. So maybe you can tell the people.
Yeah, sure. So, of course, there's a nice Wikipedia definition of operational excellence. And if you're a manager, then probably you'll love this because it talks about principles and tools and continuous improvement. You want to improve the value to your customers. But, of course, we're mostly developers probably, or like who here is a developer? Okay. Any managers in the room? Few managers, okay. So sorry if I offended you.
We gotta be careful what we say.
But I mean, okay. So what does it mean to me as a developer? So like Alex mentioned, it's about caring about your customers, about your production environment. It's about not seeing your work as finished the moment your PR or merge request is merged and you continue on to the next task. You want to know that the system you're building is running smoothly, is doing what it's supposed to do, the way it's supposed to do it. And it's not just being reactive to let's say, like bug reports or something. It's also about being proactive. Like you should be able to foresee any issues and fix them as preferably before they occur.
So maybe a quick question. Who here actually does think that their job is done when a pull request is finished?
Very good. I'm proud of you.
Okay. So, who here by any chance has a DevOps team above them that actually takes care of the provision to production and things like that? All right. And who here is responsible for their own infra and everything and needs to make sure everything is running? Okay. All right.
Yeah, that's what you see nowadays,
Yeah,
right?
that
It's
is
more and
that
more,
is what you see nowadays. Yeah.
yeah, and even if you're dependent on some other team, like it's not like a sole responsibility of the developers, right? You work as a team, so it's everybody's responsibility to be able to achieve this operational excellence. Yeah. And I have to say, it's for us, it's also been a journey. I mean, we've also had situations where something wasn't working and we didn't notice. And yeah, the moment when something like that happens, especially when you're giving a demo to a potential customer, that's not nice, right? So of course, we were also improving on that process and adding some alerting. But yeah, just having alerting in place is also not enough. I mean, you also have to react to that, right? You have to, so it's more than just having the technical tools in place, it's also about the mindset. Ultimately, you want to go towards this situation. Of course, preferably you don't want anything to go wrong, but inevitably things go wrong and you want to be able to be on top of that.
It is a very good feeling when somebody tells you, hey, something is breaking, and then you can answer with, okay, we know the fix is already on the way.
Yeah, exactly.
Doesn't happen often with me, but you know.
I tell you when you broke something.
Yeah, that is true.
So yeah, so how do we achieve this operational excellence? How do we reach that? It's mostly like initially about limiting the unknowns of your system. So you want to be able to have a good feeling about how your system is running in production, and that's not just the technical part of like how fast your server is responding to requests, but it can also be, for example, like business metrics, like how many customers are doing a purchase on your website, let's say something. So it's both technical and business from business perspective, being able to know how your system is running and also being able to predict what a potential change might have as an impact on your system.
So talking about unknowns, who here works with microservices? Oh, not everyone. Just out of curiosity, who is working on a monolithic architecture? Ooh.
Should we say lucky them? Or
yeah, I'm not sure actually. But who the people that work in microservice architectures, who has like the feeling that they really know everything there is to know about the whole landscape from A to Z? There is one Superman over there.
We're not going to quiz you, no worries.
So yeah, there's a lot of unknowns.
Yeah,
right? Yeah.
and it's difficult, of course. But,
Yeah.
yeah, so let's talk about observability, because in order to limit these unknowns, observability is a way of helping you achieve this level of information, knowledge about your system, let's say. But before we continue, we're going to ask you to participate.
Yeah, I'm sorry. So yeah, it would be a little bit boring, we thought, to just give you some traces or logs we generated. So we're going to try to generate it together with you on stage. Hopefully our server will not crash.
It won't.
Yeah, well, I built it, so.
Then, no. Yeah.
All right.
Yeah, so we developed a game called Tracy Bird. Well, I mean, the game design is mostly this guy because he's...
it is award deserving,
yeah.
that's for sure.
It's definitely award deserving, but it's basically an operational an observability platform and enterprise grade award deserving game. Huh?
All right, yeah.
Yeah, you want to...
let me start up
the session? Yes, and then we're going to ask you to take out your cell phone or laptop if you have it.
We still quickly have to talk about the architecture.
We're going to talk about the architecture first.
Well,
okay.
I mean,
yeah,
the
sure.
general.
Okay, so what we did, now we know why we're calling it enterprise grade. We created our own microservice architecture. So what you see is, here are you guys, this is us. We have a web application called Tracy Bird. It's basically let's say HTML, static HTML with some nice JavaScript that talks to Kotlin backend, of course Kotlin. And we have a sort of like a management interface that's built in a .NET backend, and it's .NET because of this guy. And also to have some like more multilingual aspects in the whole architecture. And both these services talk to a persistent service, which in this case is another Kotlin service, just because we love Kotlin so much. Of course, we can also put a database behind it, but because we're doing this demo like multiple times, it's easy to just restart the server and then we have a clean persistence, let's say.
So we made it a little bit more verbose than it needed to be.
Of course, enterprise.
Enterprise, yeah. Just also to show what observability can mean for you.
Yes.
So with that said, if you could scan the QR code.
Or just go to the website.
Or go to tracybird.com. TM, copyright patent pending, by the way. I leave it up, and then you can enter your name. And it's a Flappy Bird type of game. So I hope you liked Flappy Bird back in the day.
Inspired.
Inspired by it. And this is all you people playing right now. So we can see there are a couple high scores. We have Macon and Jellyboy and Erik. Well, I think who that is. I think I know who that is. So it is beautiful to see it work. So we've heard before that the game is maybe a little bit tricky, not for Andreevs or Riccardo A. The server is holding quite nice.
Of course.
That's quite nice to see. So what this all means, we'll let it go for a little bit. What this all means, you'll see in a moment. But for the people that play, who thinks it's too hard, that the game is too hard?
Told you.
And so many people always tell me it's way too hard, but then I'm like, yeah, I play Dark Souls, so this is really not that hard.
Some of us don't have time to play Dark Souls.
I'm hearing people like, this is impossible.
I mean, 13 is not bad, right?
Yeah,
that's pretty good.
I mean, my personal high score is at 27, just so you all know.
Of course.
Just have to throw it out.
Yeah.
All right, I've got to stop it now.
Yeah.
Thank you all very much for playing. So before we show you what you all generated and what happened under the hood, we need to talk a little bit about 3 pillars of observability, right?
Yeah.
Logging, metrics, and tracing. And well, this is a very nice Greek temple.
Yeah, I mean, just a bunch of pillars doesn't make a temple, right? I mean.
That is true. Say that to the British. Yeah. So logging, metrics, and tracing.
Yeah, so typically when people talk about observability, they mention these 3 pillars: logging, metrics, tracing. I think, like, okay, who here uses logging? Probably most of you. Oh, that's not that. Yeah, okay. Metrics. Okay, tracing or distributed tracing. Oh, okay.
So we see that often. Like
yeah. Well, I would have expected more logging, to be honest. But
a lot of people log, metrics a little bit less, and tracing is not so popular.
But typically, when you're saying that they are pillars, you kind of put them in separate columns. While in our view, it's basically a collection of telemetry data that are like intertwined with each other. Let's say. Especially, like when you're tracking some production bug, you're going to look at both the logs and the metrics, and you're going through your traces, and they are all connected. So it's not necessarily 3 separate pieces of information. They are combined into what we can call telemetry, right?
Yeah, and I really like the quote we showed a little bit earlier. Like, if you're working in microservices and you get an error, it sometimes does feel like solving a murder mystery, right? So you see an error somewhere, and then you start diving in, and you are going from service to service, checking the logs of each service, trying to find, okay, something went wrong here, but it went wrong because something else failed. So then you go to that service, etc., etc. It can be quite the pain. Or at least I feel it's quite the pain.
No, it can be. You can also view it as a challenge. But yeah, it's nice if you have the proper clues in place, let's say, to be able to track the issue, right?
Yeah. Yes.
Yeah, basically.
So yeah, what is OpenTelemetry for the people that?
Yeah. So OpenTelemetry is basically a way of standardizing this telemetry data that we mentioned before. It's 100% free. It's a collection of tools, APIs, SDKs. And it started out as a like a merger between open tracing and open census. I don't know if those terms are familiar to you, but basically there were two standards being developed. And probably some of you know like the XKCD reference, like, hey, there are competing standards, we have to fix that, so let's create a new standard. And in this case, that was OpenTelemetry, and I think in this case it worked out well for a change. So it's an open standard, language agnostic. We'll show you the list of supported languages later, but there are a lot of them. And it also provides integration with a lot of common telemetry apps and libraries. So maybe you're already using some tool that's OpenTelemetry compatible. And it's backed by the Cloud Native Computing Foundation. So it has some good backing from the community, and seems like it's there to stay, right?
Really important to know for the people that know what happens in the open source landscape nowadays. It is virtually impossible for them to change the license on OpenTelemetry SDKs. So it's going to be open source forever, pretty much, which is quite important, I would say, nowadays with what companies do with their open source projects, right? Yes.
So yeah, OpenTelemetry consists of three key components. Let's say the first one is the generation of telemetry with telemetry data with instrumentation. Typically, you see two variants. One of them is the code-based approach, where you, for example, you add a library to your application and you do some configuration code, and all of a sudden you have all the telemetry being collected. There's also more like zero code approach, where you can sort of automatically instrument your applications by, for example, in the case of JVM, there's a JVM agent that runs with your application and injects the code needed to do this telemetry. For both of them, there are pros and cons. Like typically with the code-based approach, you have more configurability. You can configure your own metrics. You can do more specific things and leave out the things you're not interested in. And with the zero-code approach, it's like automatic setup, and you get a good default set of telemetry data, and you can expand it if you want. So once you've generated all this data, you need to collect it somewhere. That's a thing called the OpenTelemetry collector. And that collector component is basically responsible for receiving this telemetry data from different sources. That can be applications, but it can also be your cloud infrastructure, any component in your system. And it can do some processing. I'll explain later what kind of processing is possible, but it can do all sorts of things. And ultimately, this telemetry data can then be exported, the logging, metrics tracing, to some, for example, some external tool, which I will mention a few, and we'll show them now as well.
And there is a significant chance you're already using OpenTelemetry without realizing you're using OpenTelemetry?
Or at least something OpenTelemetry compatible.
Yes, exactly. So who he uses Spring Boot, for example, for their so Spring Boot, and who uses the actuator health point for Spring Boot, right? So that is all OpenTelemetry compatible stuff.
Yeah, exactly. With some minimal configuration.
Yeah, exactly. So super easy.
I think also for the other major frameworks like Quarkus, there's also.
So any Quarkus enjoyers here? Any, what else do we have? Ktor enjoying here? Figured.
Want to go through the whole list?
No, that's it.
Yeah.
So, so we basically made an, well, you could call it a game server.
Yeah.
That is hopefully completely visible and observable in everything and anything.
Exactly.
So
how did we do that? Well, basically, here we have the architecture diagram again. And what we did with the OpenTelemetry, we basically incorporated the OpenTelemetry components into our infrastructure. And basically it looks like this. So the services, the backend services, they have all been instrumented, let's say, with an agent that collects the data. So in the case of the Kotlin backends, we added the JVM agent that automatically starts up with the application and collects the data. For .NET, there's a DLL that gets loaded on application startup. And we, in the browser, we've added some JavaScript code that initializes this OpenTelemetry collection as well. And all of that data gets sent to that OpenTelemetry collector component that I mentioned before.
Yeah.
And the collector exports this data, in our case, to Grafana. We chose Grafana, but of course you're free to use any other tool.
We're
that's
not trying to peddle you Grafana. There is no association between us and them. Well, except the fact that they send us a marketing email once in a couple of months asking us to pay.
More often.
A little bit more often, yeah. So I guess you could say things are getting serious.
Yeah. Yeah, so you might ask yourself, okay, why is this collector in place here? Why can the data be sent directly to your external tool? So, as we know in software development, like coupling and cohesion are big things. You know, like you want to sort of like abstract things away. And in this case, the fact that we are using Grafana should not be an issue for any of the backend applications. If we decide to switch from Grafana to something else, then we don't want to change the configuration in each of the services, but we just have a central point where we say we want to change the export to some other tool. Or we can also add like multiple tools. If we say, for example, we want our logs to be sent to this tool and our metrics and tracing to this tool. There are all sorts of ways in which you can configure how to export that data to different tools.
Yeah. So a very popular tool for this is Elastic. The Elk stack, who uses the Elk stack for their microservices, for example. So you can basically almost drag and drop or replace Grafana with the Elk stack, and you're there.
Yeah, because the Elk stack also, so Elastic also supports OpenTelemetry.
Exactly.
So in that case, we just replace this part with Elastic. We can even have them side by side. So if you say I want to send the logging to both tools, that's also possible. And maybe if you're in some complex cloud infrastructure system where it's like, for example, there are some compliancy issues or some limitations to your networking, for example. The benefit here is that you only need one line outside, or if you have one too, of course. But you don't need to allow every individual service to access the internet. You can just say, okay, they can send their data only to this collector, and the collector is the only one that can reach the outside network. Yeah. And next to that, it's also possible to do some filtering here. So let's say you have some sensitive logging. You want to do some filtering on it before you export it to some external tool. You can also do some like pattern matching and add some rules to the logging to say I don't want this part of my log to go to an external tool. So it's pretty configurable and
some obfuscation.
Obfuscation,
yeah.
yes, and batching, stuff like that.
But unfortunately, to get this to work, you need a little bit of YAML.
Yes.
Anybody that
not
loves
that much.
YAML? Huh?
Not that much.
But anybody that loves YAML here by any chance?
We've never encountered someone that loves YAML.
One day we'll find the chosen one.
Yeah. So what we see here is Kubernetes config map that configures a JVM application to do OpenTelemetry exporting of their telemetry data. So it's not that much, though. Like we enable the Java agent with a global flag. We specify the endpoint, which in this case is just an internal endpoint in our Kubernetes cluster. It's just internal network call, basically. We say we want to export traces, metrics, and logs using the OTLP protocol. Because we're running on Google Cloud, we can enable some Google Cloud specific things so that even the Google Cloud specific properties are added to the logging. So for example, you see like the name of the Kubernetes pod that your application is running on, stuff like that, the cluster, some information. You can do some sampling. So for, in our case, we just sample everything, but maybe if you're running in some environment that has a high load of requests, you want to say, I want to do only a certain percentage of requests, etc., etc. We instrument micrometer, which is what Spring Boot uses under the hood with the actuator endpoint to gather the Spring metrics. So in this case, this allows us to export the Spring metrics also via OpenTelemetry. And we just increase the interval to have some faster feedback.
So configuration is quite minimal. And for the .NET service?
It's pretty similar in the sense that you have to set up some properties. In this case, add the the DLL which gets added to the startup.
So as you can see, it's all kind of similar across landscapes. So it's not that one is much more tricky than the other. Well,
no. And then there's JavaScript.
Yeah, there is JavaScript. That is true. So this is a little bit what you need to do for JavaScript.
Yeah. So just quickly, again, we specify the endpoint, which in this case, of course, must be a public endpoint because, well, people are running the application in their browser. So in this case, the OpenTelemetry collector needs to be accessible via the internet, which you can, of course, also like decouple with some like firewall to prevent certain endpoints on the collector to being called. But in our case, we just added this trace endpoint, so it's accessible from the internet. We specify the name of the service. In this case, is the name of the game. We can add a version, and we add some processor configuration that says, okay, we're going to batch the spans, which are like the parts of the trace when you're interacting with the application, so that we don't overload the service, but we batch some requests. So pretty straightforward. And then here we have some instrumentations. What you can see here is, okay, we want to have some information about the document load, like how fast is the website rendering in your browser. We instrument some user interaction, so basically events like click or if you tap on your screen. Yeah. And we instrument the fetch call, which is basically the HTTP request that we are making from the application.
And in the end, so we have a Kubernetes cluster running,
yep.
And this is a little bit how it looks within the Kubernetes cluster. So we have the .NET, the Kotlin backends, and you have like a collector for your backend services and a collector for the front end, and an agent that does the collecting.
Yeah, basically, because we are deploying a collector on a Kubernetes cluster, as you might know, Kubernetes runs the applications on different nodes in the cluster. And to add some performance to it, the OpenTelemetry configuration installs an agent on each of the nodes in your cluster, so that the application can basically send the data over local network, and the agent will do the remote call to the central collector, which then can export to the internet, let's say. And in fact, an OTel agent in this case is basically another collector, but it's called an agent because it has a sort of a different role. But that's all. Basically, you get it automatically if you just use a Kubernetes installer for the OpenTelemetry collector.
Yes. And everything is green, so that is good for us.
Yes, very good.
So yeah, maybe let's take a look at the traces we generated,
sure.
right? These are the traces basically that you all just generated a couple moments ago. Maybe if I go to the last 50 minutes. Oh, there we go. Last 5 minutes. Was it 5 minutes ago? No, right. It
feels like longer. People are still playing, I think.
Are people still playing? Yeah.
We saw you.
Gotta defeat that high score, huh? So, and again, so we're showing this in Grafana, but this can be anything. It can be Elk, it can be Datadog, it can be. We'll show you some alternatives later. If you want, you can even render it in ASCII in a console if you're brave enough.
It's an open protocol, so you can write your own observability tool if you want.
Yeah. So yeah, here we can go to and basically there we go. And then you can view a trace, and this is basically a trace of everything that happened from the click all the way to the persistent service. And you can see that this one took 3 seconds to complete from start to finish.
Yes.
And then you can go to the span attributes and things like which URL was it. If there's anybody, by the way, that is like, okay, I want to know, show me this, shout, and we'll try to find it. No guarantees, though. So don't be shy. So yeah, and then of course, if you want to see here. And here you can also see that we added some spans in the traces, and spans are like
span attributes.
Span attributes.
Yeah, they're basically like key value pairs A lot of them are like delivered to you out of the box, but you can add your own, as you can see here. Okay, so this is not like recommended in production, probably if you have like sensitive user information. But in our case, we're like, okay, it's nice to add some information. So in this case, we added the player ID and the player name as attributes to the spans, so that you can see in the traceability tool, okay, who was it?
Who was it? So who is Carapas? A little bit shy. Okay, that's fine.
So if you scroll a little bit to the top, you see that there's actually like the click in the application, in the web application, that leads to the post, that leads to the backend call, which leads to the call to the persistent service. So you see the full trace throughout the system.
Through the whole system, yeah, from start to finish. And it's really nice that you can see also how long it took and where, if you have bottlenecks, what the bottlenecks are and things like that. As you can see, there was some internet hiccups, which
I mean,
makes a little bit
you're a gamer, so you want like zero lag, right?
A ping of 10 and a frame rate of 120 frames per second, please. So as you can see, there's a lot of information to get out of the traces, almost right out of that with, I don't want to say minimal configuration, but also not a lot of configuration.
No.
Right?
Exactly.
Yeah. All right. And well, those are traces, but also kind of interesting are metrics.
Of course.
Yeah. You get a lot of metrics right out of the bat. So I think you get like 123 or so metrics right out of the bat, and
a lot of them are just like the Spring Boot actuator metrics,
exactly.
which
so requests active, GVM stuff, garbage collection, etc., etc., etc. And you can add your own metrics as well, but we have I think better here. So this is what you all did. A high score of 13, and combined you all died 926 times. Which quite interesting, actually. But this is really...
There were some attempts.
But this was really eye-opening to me also when we first started talking about adding metrics, is that at least when you hear metrics, you immediately start thinking about response times, 500, how many error rates you had, GVM pressure or a heap pressure, etc., etc. But it can be really anything. It can also be maybe a little bit more businessy metrics, so to say, to make your product owner happy that he can just log in Grafana or Elk or whatever, and then just look at some dashboards like, oh, whoa, this is green, it's so good, they're doing such a good job. I'm going to give them all a raise or something like that.
Would you also maybe recommend some gamification?
I mean, I'm always in for gamification, but
I mean, you make it fun, right?
Make it fun. Yeah, I love making things fun or playful, and I have to say. So a couple months ago, or 2 months ago, we gave this session somewhere else, and somebody had a high score of 333. So I don't know what you all are doing here.
But we know what that guy was doing.
We know what that guy was doing. He found a bug in our code who kind of and exploited it live on stage and put a high score for himself.
But we fixed the bug. So,
but we fixed the bug, so you cannot do the same thing. Or at least, well, better said, we think we fixed the bug.
We fixed that one.
Yeah.
We don't know what we introduced.
Yeah, but of course you can also have server requests and the more developer metrics quite easily visualized. So basically anything you could wish for, you could probably add a metric for, and the code to add a metric is quite. I mean, you've done it with Micrometer, if you Spring Boot, it's pretty much straightforward and the same. But if you want to see it, just shout and we'll show it. Yeah. All right, and then we have, of course, the last one, logging, and that is something that everybody maybe struggles with. We've had a lot of discussions about logging in our team. I sometimes feel we are logging too much, and the sheer amount of logs is kind of numbing me from looking at the logs, so to say, right? So it's so much, there's no way we'll ever find the information we need there.
Yeah, and I was more like, okay, let's gather the logs, then at least when we need them, we have them, and we can search through them. But yeah, then you have to have the right tool to search through the logs, right?
Exactly. But we're not going to show you the Tracy Beard logs. We're going to be needing you one more time because we made another game, Logarithm, which is actually very on brand for the theme of the conference. We didn't know, but it is a little bit of a rock game. So I hope the sound is working. Wait, let me start the session again. First, here we go. So the idea here is, who here knows Twitch Plays Pokemon by any chance? Anybody heard of it? A couple people. So the idea is that you all together try to play a guitar riff. And this is the riff that you all will try to play in a little bit. And you can find it here, or go to tracybeard.com/logarithm. I have to say we are pretty spot on with our naming for our games.
Yeah.
Yeah, right. The sound works. So we generate a lot of logs now. But thankfully, we can find out who those participants were. But we're not going to name and shame. Or are we? No.
Well, we're not going to shame.
So as you can see in these logs, basically every click that was done was logged in with emoji, by the way.
Very important.
Very important.
Support for emoji.
Very important. So here we can log basically only the errors. And every wrong chord, rocker Joe messed up with the jam with a wrong chord, for example. Or Ze Miguel messed up with a wrong chord. We know. What did you think?
Hey, we're not going to shame.
Oh yeah, we did. We're not going to shame.
Just name them.
No, but we appreciate that you are that everybody participated.
You tried.
Yeah, and then we can go to show the logs. There we go. And then we can click here. And what's really nice is, okay, then you see a log that is interesting to you, that is maybe an error or whatever. And then you can here basically go to the log and immediately just click through and immediately open up the traces of that certain log or where the log is connected to. And from those traces you can basically see everything, the whole chain that caused that log to trigger, to fail, or the warning to trigger or whatever. And that is not something that Grafana does for you. Well, I mean, to a certain degree.
But I mean,
but
OpenTelemetry.
But all the information is coming from OpenTelemetry. So that is really what enables you to make everything observable within a couple of clicks, from log to traces, traces to logs to metrics, etc.
Yeah, instead of having these separate pillars, it's all integrated.
Yeah, exactly. Which for me was kind of an eye-opener, I'll be honest, when because I was really used into, you know, well, let's say we do Java system.out.println, like this is running right now, and then a couple lines under system.println, this line is reached now, you know, and stuff like that, and then deploy it on staging, see what happens, and stuff like that. Yeah, very old school. I know. All right. But yeah, in the end, do we always need OpenTelemetry? That is probably also a question that some of you thought about during this session, I would guess.
Yeah, so it's mostly beneficial if you have a diverse tech landscape, you know, like different services in different languages that all export their data in a different format. Then it's nice with OpenTelemetry to standardize that into a single language, let's say. It also allows you to be more vendor agnostic. I can show you how many, these are just a number of the the observability tools that are supporting OpenTelemetry. But this way you're not like limited by a vendor lock-in. So if you have a certain observability platform or tool and they decide to increase the prices, you have the power to say goodbye and go to a different tool, right? With,
so long.
Yeah, exactly.
Exactly.
And yeah, because so many tools are already supporting it, maybe you're already using a tool that supports OpenTelemetry, so you can also extend it easily. Or let's say you are using one of those tools, but you're using their proprietary protocol. You can also gradually switch to OpenTelemetry and then like phase out that external tool if you want. But on the other hand, if you're just like you have a tool and it works for you, and you're not like you don't have that much of a diverse landscape, then it's fine to just stay with that tool, right?
I mean, yeah, I guess if you have one monolith, and that is really all that you're maintaining, I mean, it's fine to just have something that makes that as observable as possible, and that's fine. You don't need.
True. But nowadays, a lot of us are like running in the cloud, so you also have some cloud metrics, which can also be integrated with OpenTelemetry. So,
anybody here that really feels that have the whole observability thing nailed down for their landscape? Okay, well, that's also how we feel. Still,
I hope we gave them some ideas.
So hopefully, yeah, true.
Yeah, so just a quick implementation status update. I'm not going to name everything, but if you see your language here, then you can see in what state the traces, metrics, and logs part of the specification and implementation is. So yeah, for Java, it's all stable, ready to be used. And there are also more specifications on the way. So OpenTelemetry currently supports logging, metrics, tracing, but they're also working on 2 other specifications. One of them is profiling. So having a standardized language to export profile information from your application to external tools, so you can switch the profiling applications as well. And real user monitoring, so that's basically tracking how users interact with your website through like their mouse movements and how they navigate through your screens. They are also working on a standard for that. So a question.
That was the first thing I told you, by the way, when you started. Yeah, but what about the performance?
Yeah. Is there a performance cost? Yeah, of course there is some performance there's always like a little bit of performance needed to generate and export this telemetry data. Overall, we see that it's at most maybe a few percent. It's not that big. Of course, it also depends on your use case. Like I said earlier, with tracing, you can have a certain sample rate. So if you have like a lot of requests per second, you might not want to trace all of them. You can sample a subset or sample only the request that went wrong, stuff like that. So there's something to be tweaked there, let's say. But yeah, there is a performance cost, of course. But yeah, I mean, if you don't measure your system, how do you even know that there's a performance impact, right? How do you know the performance of your application if you don't measure?
I'd have to say, if somebody says that to you, the quote that you said to me back then, if you're heading towards disaster, you don't want to go faster. That is like a straightway argument-winning quote. That's
exactly. Yeah, another thing worth mentioning is that it's not a static impact on your system. So you can change the way you do observability over time, right? And in the beginning, when you start working on the application, you might not have that much confidence in how it's running in production. So you might want to add some more telemetry, get some more insights in how it's running. And then over time, if you see that your metrics are very stable and it's handling the load pretty well, you might want to say, oh, I can reduce the amount of logging I do, or I can trace less requests. You know, it's a dynamic thing. And regarding the logging, what I mentioned earlier as well, that if you want to know how your feature is running in production, it might be good to have more logging temporarily until you have a good view of how it's running, and then you can reduce it. It doesn't need to be fixed like that forever. Yeah, so final words. We are almost out of time. There are multiple ways to reach operational excellence. I value it a lot because I see I've seen what happens if developers are not paying attention to it. And we hope that with this presentation we gave you some inspiration to work on it and to improve it. But ultimately find a way that works for your situation. There's not a one-size-fits-all solution, but with OpenTelemetry you can at least play around, switch.
So in the end, it's about confidence, right?
Yeah,
like
exactly.
that you have the confidence, the peace of mind when something goes to production. If something happens, you'll be the first to know, and that you'll be very quick into finding out why that something happened without having to solve a whole murder mystery, play Cluedo in AWS CloudWatch or something like that.
Exactly.
Right? So yeah, with that, I think we have to say thank you very much. Yep. Thank you very much for playing our crappy games. On the top link you can find the slides if you want. All the backend code is on GitHub, so if you want to see how we created the games for any reason, or more importantly, how we added metrics and tracing and etc. in there. You can find it all on GitHub. I'm on Blue Sky. If you want to say anything to me, you're on LinkedIn.
Yes.
What the OpenTelemetry website is, that's pretty straightforward.
Yes.
So thank you very much.
Thank you.
And we do have
3
minutes or so for questions. If anybody has a question, by any chance.
I see there a few there.
Yeah.
Do we? Well, there are some observability tools that you can run internally in your own cluster. So yeah, in case of Grafana, for example, you can run a Prometheus instance for the metrics. It has, I think, Loki for logs you can run, and Jaeger for tracing. There are like open source tools that you can configure and run within your own platform, so it doesn't even leave the cloud, your own private cloud, let's say.
Yeah, so it will take a little bit more configuration, but you can do it all with a little bit.
There are a number of example projects out there that should help, but yeah, ultimately, of course, it's more work than going for a cloud instance.
But you can basically self-host everything.
Yeah.
Thanks. Yeah. Hi.
You mentioned that the correlation between the logs, metrics, and traces was being done by OpenTelemetry itself.
Yep.
I just wanted, because I thought that was a thing that was done by Grafana, but I got curious.
Yeah, so it's a Grafana feature, like we use the Grafana feature to show it, but Grafana is the one that added the link, like click here to go to the trace belonging to this log. So that part was done by Grafana. What OpenTelemetry does is it basically takes care of managing the trace IDs. That like it creates a trace ID for every let's say interaction with the system, and then a span ID which is part of the trace for each individual step in the whole interaction. So let's say the post to the backend service, and then from the backend service the post to the persistent service. Those are all spans. And what the OpenTelemetry configuration does for you is make sure that it propagates that ID throughout the system, and ultimately it passes that ID to Grafana, so that Grafana can correlate all these data, all these pieces of telemetry data with each other.
So does that trace ID has to be in the logs as well, so that they can
It is, yeah.
It is.
Yeah. So basically, the logging, I'm not sure if you're familiar, in Java you have the MDC context, like the logging context, which basically are some key value pairs of information that can get added to log lines. And those key value pairs are propagated like when the telemetry data is exported.
Thanks.
Yeah, sure.
Yeah, so we have a timeout,
Timeout.
just there.
If you have any other questions, come to us.
Thank you very much.